So here, just like in arithmetic sequences, if we want to find the sum, we have another formula. So again, this formula looks complicated, but it's not. Same thing. You just plug in or substitute the numbers that we have. If we have a ratio, you put it in for R. If we have the first term in our sequence, put it in for U1, and then we solve. But we have 2 here. If R is less than 1, we put it in the bottom one. If R is greater than 1, put it in the top one. And you see this little funny looking E up there. What that means is sigma. Sigma means summation. This is sigma, that means sum. So both these equations can be represented by this. What it's saying is I might have an n equals 1 here. Then I can have my formula a1, that's my first term, or I can see u1 times r to the n minus 1. We're just using our formula here that we know. And then this is, let's say we're going to go up to 17. What this means is I start here, start, and then end. So on the top here, that's how many terms you're going. I start at 1 and go to 17. I'm finding the sum of the first 17 terms. That's what this means. So whenever you see this, don't panic. It means sum, and then you can just use one of these. So here, so for example, if you see this, let's say this is 5, this is n equals 1. My equation is, I'll say 3, 2 to the n minus 1. What this means is I'm going to find the sum of the first 5 terms. So that means I'm going to do, if you do it by hand, it's like this. 3, let's start at 1, 1 minus 1, plus 3 to the 2, 2 minus 1, plus, and I'm going on like that. But so that you don't have to do that, that's why you use one of these formulas, either this one or this one. And since my ratio is 2, 2 is my ratio, that means I'm going to be using this one. And I would put my 5 here, my u1, I'd solve this to figure out what it would be, and I'd put that here. So if you see that, if I put 1 minus 1, that means you get a 0 here. So 2 to the 0 power is 1, so my first term would be 3. And then ratio is 2, so 2 goes here, 2 goes here, like that. So once I know everything, I'm just plugging it in, just like the arithmetic sum. So here, perfect IB problem, they say, what's the common ratio? Again, you just divide 16, or 8 divided by 16. Yeah, see that? 8 divided by 16. That's it. That's how you find a ratio. It should be 1/2. So then if you know the ratio is 1/2, finding A and B should be really, really simple. So right, A has to be 4 because 8 divided by 2 is 4. 2 divided by 2 is 1, I promise you. So they give us the sum. This is Sn. They give it to us. 31.9375. Find the value of n. Okay. Well, do I know the first term, u1? Oh, there you are right there. u1. 16. And we're using this because 1/2 is a ratio that's less than 1. So I'll say, okay, 1 minus 1/2. And I don't know that. That's what I'm looking for. Over 1 minus 1/2. So this will be straightforward. You just solve for that. This is simple algebra because you'll end up with this 1/2. So you multiply both sides by 1/2, and then you get 31.9375 over 2 equals 16, 1 minus 1/2 to the n. Then divide both sides by 16. You'll end up with 32 down here equals 1 minus 1/2 to the n. And you just subtract 1 from both sides, and you just continue like that. But if you wanted to, you could even stop here, graph that y1, graph that. I would actually prefer to solve that by hand, but it's up to you. I don't mind. I don't judge. You do it how you want to do it. Katie, this would actually be a good example of using log, because if you look here, our variable is an exponent.